Alright, so welcome back to my YouTube channel. So in the last class we looked at differentiation of algebraic fractions using product rule, and I told you that product rule is when you are having UV, that is the functions are placed side by side or they are multiplying each other. But now in quotient rule, it is when the functions are being given are dividing each other, so u over v. So let's look at the formula. The formula is v du dx minus u dv dx over b squared. Now, the examples here, we have two examples on the board. Use the quotient rule to differentiate 1 minus s squared over 1 plus s squared, and also s squared plus 1 over x plus 1 all squared. Now for number 1, we have 1 minus x squared over 1 plus x squared. Now you know that this one is your u and this one is your v. So in the formula we have du dx. So let's differentiate du dx. So du dx is this. When you differentiate this one, it has turned to 0. That will be minus 2x. Minus 2x. Differentiate dv dx. That is, you are differentiating v with respect to x. So this one has gone to, we have plus 2x. Now to put it into the formula, that's dy dx equals, what's our v? Our v is 1 plus x squared, that's our v, and du dx, that's v du dx is what? Minus 2x. That is for this. Then minus our u is 1 minus x squared, then our dv dx is plus 2x. Everything over v squared. Our v is what? 1 plus x squared, everything squared, because v is 1 plus x squared, then everything squared. That's for this. Now the next thing to do is to find what is common. What is common? Now what is common between this and this? If I have to look at it very well, what is common is there is minus 2x here and there is plus 2x here. So it means that when in your plus we have minus times plus, okay, let's take it like this. In minus gives us plus times minus. Yes, minus gives us plus times minus. Plus times minus. So when we pick we'll pick this minus out, because we have minus here and we have plus here. So we're trying to pick what is common. So what is common between minus and plus? There is plus here and there is also a plus in minus. There is one plus in minus, because in minus gives us plus times minus. So we have plus as what is common. So plus 2x is common in both sides. So plus 2x. Plus 2x is common in both sides. So when plus 2x is common in both sides, now what is remaining? 1 plus x squared is remaining here. 1 plus x squared is remaining here. And don't forget that there is still one minus here, because we said plus is common. So we still have one minus left here. So we still have one minus, which is times minus 1, which is minus. Then for this, let's put it here. The one minus that is left, minus 1. Now for this too, minus, we've taken 2x here, so this is left with nothing. So we have 1 minus x squared. Everything over 1 plus x squared all squared. So we can say it is safe to now use this minus to open up this bracket. So 2x minus 1 times 1 is minus 1, times this is minus x squared. Then this times is minus 1, this times is plus x squared. Everything over 1 plus x squared, then x squared. Alright, so 2x minus 1 will be minus 2. Then minus x squared plus x squared has gone. So we have minus 2. Minus 2. Minus 1, minus 2. This one has gone because minus x squared plus x squared has gone. So we have minus 2 left here over 1 plus x squared all squared. So at the end of the day, 2x times 2x. 2x times minus 2 is minus 4x. Everything over 1 plus x squared, then raised by 2. That's our dy dx. So that is it for number 1. Now let's have number 2. Okay, so number 2 we have x squared plus 1 over x plus 1 all squared. So I hope you know that this is your u, this is your v. So since this is your u, our du dx will now be 2x. Then for this dv dx, bring this one here. This is a chain rule. So you bring this one here, so you have x plus 1. Don't forget this one minus 1 here, it will remain 1 here, times the differential of this. Differential of this is 1, so which is still everything here times 1. So we leave it like this. Now our formula says dy dx equals v du dx minus u dv dx, everything over v squared. So our v from the formula, v is x plus 1 all square, du dx is 2x, minus u is x square plus 1, then dv dx is 2 open bracket s plus 1 over b square. V is x plus 1 all square, then everything all square, because the formula is carrying square. Now it's time for us to split and check what is common. Now what is common between x plus 1 all square, 2x, and this? Now we can see that this one, we have one of it here, we have 2 of it here, so one of it is common. That's one of it is common. 2 is common here, there's 2 here, there's 2 here, so we can also put our 2. So that is the only thing that is common. Now where we have taken 2 here out, we are also taking one of these out, so we are left with this x, because there's still one x here. Yeah, we still have this x here, and then we are left with one of these 2, x plus 1, because one of it has come outside. Then minus the whole of this guy, we have not used it, so plus 1. We have brought this out, we have brought this out, so everything x plus 1, we can make it raised to power 4. Okay, yeah, we have times it already, indices, so raised to power 4. All right, God bless you all. So we can now open up this. We have 2 open bracket s plus 1. We don't need to open this one first, because there's a tendency that we can divide it later, so we don't need to open it up. So we have, let's open the one inside bracket, x squared plus x, then minus x squared minus 1 over x plus 1 all raised power 4. So x squared here as minus x squared here. So what's left here? We have 2 open bracket s plus 1. We have plus x and minus 1. That's x minus 1. Everything over s plus 1 raised power 4. Yes. So this s plus 1 here cancels one of these. It remains 3. So we have 2 open bracket s minus 1 over s plus 1 all raised power 3. So that is dy dx. All right. Thank you so much for watching this video. If you know you understand this topic, please like, comment, and share. And don't forget to subscribe if you have not subscribed. God bless you all.